Welcome to this explainer. If you're an engineering student or a junior site supervisor, you are stepping into an environment where your day-to-day decisions have massive consequences. Today, we're running a critical, authoritative site safety briefing specifically on formwork stripping times. Why? Because in construction, relying on guesswork or just casually checking a calendar costs money, causes massive rework, and far more importantly, it literally risks lives.
Here's what's on the agenda for today's briefing. First, speed versus safety. Second, vertical versus horizontal formwork. Third, the testing standard. And finally, the risks of premature stripping.
All right, Section 1, Speed versus Safety.
Let's just address the elephant in the room right off the bat, okay? There's this constant, underlying tension present on every single construction site. The project schedule versus the unyielding reality of concrete science. As a junior supervisor, you're going to feel this pressure immediately. Look, your project manager naturally wants to speed up the pouring cycle, right? Removing and reusing formwork quickly keeps material costs down, it frees up space for other trades, and it pushes the whole project timeline forward. But as a site supervisor, your absolute priority has to be the engineer's goal. Your job is preventing excessive stress on young, early-age concrete so that the finished structure actually has the stability and durability it was designed for.
This whole dynamic is summed up perfectly by a fundamental principle from a recent IIT Delhi study on formwork stripping. It states that stripping formwork is not about simply checking a clock, it's about guaranteeing the concrete has developed the structural capability to hold its own weights plus any superimposed construction loads. Until that hardened concrete can withstand all applied stresses, those forms must stay exactly where they are, no exceptions.
Moving on to Section 2, Vertical versus Horizontal. So, let's break down the actual rules on site. You really have to treat vertical and horizontal removal like two completely different beasts. Vertical formwork, for members like columns and walls, is generally non-load-bearing. It mostly just shapes the wet concrete. According to standard codes like IS 456, this vertical formwork can often be stripped in 16 to 24 hours, provided the concrete hits a minimum compressive strength of 3.5 megapascals to prevent surface spalling. But on the completely opposite end of the spectrum, horizontal slabs and beams are flexural members. The very second you remove their props, they're immediately subjected to immense dead loads, mostly their own weight. Therefore, horizontal forms require significantly more time, often 7 to 14 days or even longer, depending heavily on the cement grade and the ambient temperature.
Now for those horizontal flexural members, the absolute golden rule you've got to memorize is this exact number. The bottom formwork and the shoring props absolutely must not be removed until the concrete has reached a minimum of 70% of its intended compressive strength. Anything less than that, and you are actively inviting structural failure.
And the mechanics of actually stripping these forms are incredibly precise. According to the American Concrete Institute standard for two-way slabs, if you strip the outer supports first, you cause a really dangerous stress reversal right in the middle strip. You're basically forcing the concrete to bend in a way it hasn't been reinforced to handle. Instead, you have to strip the middle first. This allows the slab to deflect smoothly and safely take on its load exactly as designed.
But it's not just about when you take the forms down, it's also about how they're supported while the concrete is still wet. Proper lateral bracing is absolutely critical. For example, if a slab frames in on only one side of a beam without a kicker or a diagonal brace on the opposite side, the entire beam form will dangerously rotate due to that eccentric loading. Your formwork must be rigidly braced to handle these unequal pressures before you even think about pouring, let alone stripping.
All right, that brings us to Section 3, the testing standard.
So, here's the big question. If we need to hit exactly 3.5 MPa for a column, or exactly 70% strength for a slab, how do we actually know when we've hit that mark out in the field? Well, you absolutely cannot just rely on calendar days, because concrete strength is controlled by a chemical reaction called hydration, and hydration is an exothermic reaction directly driven by temperature. This means cold weather drastically slows down strength gain. To put that into perspective, a slab poured at 30 degrees Celsius might reach its target in just 5 days, while that exact same mix poured at 5 degrees Celsius might take an astounding 37 days. If you're just following a static printed schedule, you are flying completely blind.
And that right there is exactly why the absolute gold standard on modern construction sites is the maturity method paired with field-cured cylinder testing. Here's how it works. First,
You don't just test cubes cured in a perfect, warm, cozy laboratory, you cast representative specimens and cure them under the exact same harsh site conditions as the actual structure. Second, you monitor the thermal history using embedded sensors. Third, you calculate the maturity index. And finally, you break those test cylinders at specific intervals. This rigorous progression is what actually verifies the real-time, in-situ field strength of your concrete.
Through this whole process, what you're really aiming to build is a maturity correlation curve. Think of this curve as a unique structural fingerprint for your specific concrete mix. It maps the equivalent age, which is based on the temperature history, to the actual compressive strength. When your field sensors tell you the concrete has reached the maturity index that correlates to that magical 70% strength mark, you know exactly and mathematically that it's finally safe to strip the forms.
But what happens if your field cure testing isn't fully conclusive, or, say, you get hit with an unexpected cold snap? That's when engineers can deploy non-destructive testing methods to double-check that the internal structure is solid. The IIT study provides some excellent benchmarks for this. If you're using a rebound hammer, you want a reading over 3.0 units for vertical members and over 15.0 units for flexural. Alternatively, if you're using ultrasonic pulse velocity, those sound waves should travel faster than 2.6 kilometers per second through vertical columns and greater than 3.0 kilometers per second for load-bearing slabs.
Finally, Section 4, Risks of Premature Stripping.
As future leaders in this industry, you really need to understand the grim reality of what happens when these strict scientific protocols are ignored and rushed by schedule pressures. Removing formwork too early or ripping it away too aggressively when the concrete's tensile strength is lower than its adhesion to the form lining completely destroys the concrete surface. It rips it right off, exposing the structural rebar to the elements and completely compromising the integrity and the load-bearing capacity of the entire member.
The cascading consequences of this are, well, they're brutal. You aren't just looking at an ugly finish here. Premature stripping leads to immediate slab deflection and deep structural vulnerability. It causes severe surface microcracking and honeycombing. And ironically, by trying to speed up the project manager's timeline, you trigger massive rework that will actually severely delay the project and incur huge financial penalties. Plus, if these defects somehow go unnoticed, they translate directly into catastrophic long-term safety hazards for the building's future occupants.
So, I want to leave you with this vital question to ask yourself the very next time you step onto a job site in your hard hat and high-vis vest. What's going to dictate when the formwork comes down on your watch? Are you going to bow to the pressure of the schedule, or will you stand firm on the unyielding science of the concrete? Thank you for joining me for this briefing.